Okay, folks, so today we are going to look at interpreting solubility graphs, solubility data via graph. So you should have already at this point taken down notes. So I suppose the first thing that we'll say is when we get a graph, we have to be able to interpret it. So the way we do it is we always start with whatever the X label is increases, because the X as we go this way is always increasing. So no matter what the label is, it's always increasing. And then the next thing that we do is we say what happens to the Y label. So in this graph, the Y label, it's going up this way, and we call this a trend. So they'll put it as trends or conclusion or pattern, something like this. So you have to decide what it is. So then we write it in a particular way. So for this particular graph, as the temperature increases, that's going across this way, always increasing. Then we look at what the solubility does, and as we go this way, this line is going up. So our solubility is increasing. The next thing that we can do is we can look at how much solute will dissolve at 65 degrees. And the line is already in here for you. You can see it here. So how do we do it? We find where 65 is on our axes. We make sure we're on the right axis. We draw a line up until it hits the line of best fit, and then we move across all the way, and you're doing this with a ruler, not like me freehand. And when you get here, you read off whatever that's going to be. So when you read it off, it turns out that it's 43 grams in 100 grams of water. And I'm getting those units from this part of the label. So then if we had what temperature will dissolve 30 grams. So now I have to go up to here. So this is where 30 grams is. I, with my ruler, draw a line until I hit my red line, which is about here. And then I drop down to the bottom and I work out what this is. So in my bottom, it's going from 40 to 50, that's 10. So there's 5 boxes, which means 10 divided by 5, it's going up in 2s. So my temperature when it dissolves, maybe I didn't go far enough, 43 degrees. And essentially these solubility curves, they tell us how the solubility changes with temperature. So we found that out the last day. Loads of the different solutes had different solubilities. You could get more or less into water. They were all different temperatures, but when we plot a curve, then we can see how the solubility will change. Now, have to have a definition. What does it mean to be salt? What is it when we talk about solubility? And it is the mass of a solute that will dissolve in 100 grams of water at a fixed temperature. Excuse me. Okay, so that temperature could be 20 degrees, it could be 40 degrees. It'll be a different amount, but you need to know mass in grams that will dissolve in 100 grams of solvent at a fixed temperature. So we have a different solubility curve now. And again, the question is, what is this curve telling you? So this is now the trend. The second part of the question says, why is this an issue in our world currently? So what is our trend? We said, for starters, temperature, because it's here, is always increasing. So that's fine. And now we have to look at what's happening to the solubility curves. And this time the solubility curves are decreasing down. So we finish our trend with, as the temperature increases, the solubility is decreasing. And the issue particularly for gases like CO2 is that if the oceans get too hot, the CO2 that's dissolved will come out of solution, and then that's only going to add to our global warming. Okay, so these are 2 little extra things, and we saw it in class today for one of our graphs. We have, if we draw a graph like this, and it's this perfectly diagonal line, we call it a directly proportional graph. So our X label is directly proportional to our Y, and we can only use the word directly when our graph starts at 0, 0. So now we have our original trend, which was what happens as temperature increases. So as temperature increases, in this case, our solubility is increasing, But now, because we have this line perfectly diagonal starting at 0, 0, we can now also say it this way. So that would be worth 2 ticks on your paper. Temperature is directly proportional to solubility is how we say that line starting at 0, 0. But what happens now if the line doesn't start at 0, 0, it starts maybe on your y-axis. I think we had one today where it started up here in class. So we now can only say X label is proportional. So there's no directly in this, and it's not a 0, 0 start. Okay, so that's the giveaway. Still diagonal line. So our trend still remains the same. As temperature increases, these lines, the solubility is increasing, so that still holds. And now we have this extra thing that we can say temperature is proportional to solubility. And again, that will be a tick and a tick if in an exam. Okay, so our X is always increasing, and this is our X and this is our Y. And it's what's the line doing for Y. So we're going to try the questions now on page 99 and page 100. You have to read all of your questions. So, in a school lab, a student investigated the solubility of a salt in water. The amount of salt which dissolved in water at different temperatures was measured, and our data is collected below. And then it is asking us to draw our graph. So, you have to recognize this is temperature, this is temperature. So, I'm finding temperature of 20. This is where I start. My solubility is, so this is my X and this is my Y. And at 20 degrees, only 10 grams, which is here, of salt can go into the water. And what I want to do is I want to find the part where these two guys meet. Now, you don't have to draw the lines. You can use your fingers to do it. But this is where they meet. So it's like going on a date. Solubility wants to meet temperature. And there's a little kiss. And there we go. So the next one, we look at 30 degrees. 30 degrees meets 20 degrees. They get a little kiss. We then have 40 degrees is going to meet 30. Another little kiss. So we then go 70 and 60. So 70 is here, and find where 60 is, and we figure out where they meet, and they have a little kiss. And then finally 90 degrees and 80. Meet here, they have a little kiss. Now, I don't have a ruler, and if I start playing with my tablet, it's going to go a bit weird. See, can I change my color pen? We will change it to the bright green so that we can see the line. But with a ruler, you will then draw the best straight line you can through all of your points, like so. Okay, they're usually giving you marks for plotting your points. And as I say, they'll give you some wiggle room. It doesn't have to be perfect. But if you have like one point, this point up here, then that's not perfect. You're not going to get marks for that. So they give you marks for all of your points plotted correctly, and then they give you marks for drawing your line. And it has to be one smooth line with a ruler, no little wispy bits coming off here, little tails anywhere. If you have tails, they won't give you your marks for it. So this is the graph that we drew for homework, and there was 2 questions down here. So solubility at 60 degrees, how do we figure it out? So is that X or Y? So you have a look back at your data table, and solubility was our Y. So this is solubility, so I need to find where 60 degrees. Sorry, so I'll start again. I think my graph has actually moved, so I'm not going to get the right answers for your graphs, but we'll give it a go. So it wants the solubility, so I'm going to end up somewhere over here on the y-axis when I'm done. I find where 60 degrees is, and I go up. Once I hit my red line, I go across and I read off. Now the value is going to be different than what's coming on the graph here because this has all shifted up for me. This should be down here. So, but if you were doing it off the graph you made correctly, it would be 50 grams and 100 centimeter cubed. It then asks about what can you conclude. So the conclude is the trend or it is the pattern. So you have 2 choices. The other thing is if it's 6 marks, you're usually having to say 2 things. So as my temperature increases, we're looking for solubility increasing because the line is going up. And the second thing is this is a diagonal line that doesn't start at 0, 0. We can also say temperature is proportional to solubility. Okay, we try the next question. So this one, we now have a science student investigated the solubility of 2 substances. The data for sugar is given in the table here. But there's also this line. Salt maintained a constant solubility of 40 grams in 100 grams of water for every temperature investigated. So this may be important later on because I've no data for it other than the 40 grams. So we start on this. This temperature is on my X and sugar is on my Y. So I'm going 0 and I have to go to 175. So this is a difference of 50 boxes and 175 will be in the middle of it. So I need to find 2.5 boxes roughly, and that's where I'm putting my first dot. The next is a temperature of 20, and 20 is going on a date with 200. So I'm going up this way and I'm going across this way to find a date of 20 and 200, and that's going to go here. I'm then going to go 40 and 240. So again, we said this is going up in 50s, which means every little box must be 10. So I want to, these guys want to meet here because that's where 240 starts. Then we're going 60 to 290. So 60 to 290 will be here, and we're going 80 to 370. So that is going to be is going to be here. And then last but by no means least, 100 goes to 480. So 480 is going to be here. Now, this time our curve is not a perfect straight line. There's a little curve to it. So you may have to fiddle your page around, but it needs to be one smooth curve through all of the points like so. It's to get your points for plotting and to get your points for drawing your line. Okay, so we go and we have a look. This was the curve that was drawn and these were our questions. So use the graph to estimate the increase in solubility from 50 to 70 degrees. So I have these two numbers and I want the solubility. So I need to find out what the solubility is at 50 first. So 50 is on my y-axis, these are on my x-axis. So I find where 50 is here. I go up to here, I hit the curve and I'm going to go across. Boom, 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 boom. So again, this is a difference of 50. So I don't know whether my curve has moved, but this is, we will say 260. The other number that's mentioned is 70 degrees. So I'm going to start here, go up, hit my curve and go across. And when I go across, I'm going to hit here. So that is 310, 320. So then I take one from the other because it's to estimate the increase in your solubility. So it would be 320, take away the 260. So that should give me 40, that should give me 60 grams. That is the increase in my solubility. It then asked, use the same grid, draw a graph of the effective temperature on the solubility of the salt. Okay, and that is the 40 grams per 100 centimeters, 100 grams that was constant. So all it wants you to do is figure out where 40 is, which is here, and then you're just with your ruler, not with your free hand like me, drawing your line all the way across, and that was your second set of points. I hope that makes sense. If it doesn't, please, please, please get in touch, and we'll see can we problem solve for you.